The continuation of the question, we have to label the axis and then we have to mark the points. What are the points? It's 45 and 39. So 45 and 39. So this is 45 and 39. Then next one is 40 and 34.3. So this is 35. You can label in between like 31, 2, 3, 1, 2, 3, 4, 5. So this is 40 and 30. Now this will be 34. This will be 34.5. So this will be, this was 30, then 40, and then 45. The next one is 35 and 30. So $35 and 30. A is 35, B is 30. The next one is 30 and 25.2. So 30 and 25.2. And then the last one is 25 and 21.4. $25 and 21.4 from what here. So these are the points. Maybe my point one due to the screen may have some error, but it will be a same pattern. Then what we do, we try to draw best fit straight line. Best fit straight line, like number of the points above and below should be same, or all the points lie on the line. That is one thing. Like if maximum points are lying, one point is above and below, that's the best fit straight line. So when I join these points, and it's not like it's you have like a best fit straight line always start with the first point and ending at last. You can join the maximum points on the line, but it should make a pattern. So best fit straight line idea is that the number of the points above and below should be same. So this point is lying on the line approximately. This point is below the line and this point is above the line. The next part we have to draw, we have to find the gradient and show clearly on your graph how you obtain the gradient. So how we obtain the gradient, you have to take any two values. Don't take the same points which you use to plot a graph. You're not supposed to take the same point. You take first point, like take any point. Length of this line, it's up to you. You can draw y2 minus y1 or x2 minus x1, but try to take about 5 centimeter distance or spacing between the 2 points to have a more accurate result. Longer lines, more accurate or close to accurate result you get. So take any 2 points. So this one I took 25 is there and 29. That is x1, y1, and then I took take another point. You have to show these lines on the graph. Like show clearly on these lines should be visible when you're working out the gradient. Or you can also use a triangle method, like just make a triangle, but better this way, so it will be convenient. X1, y1, x2, y2. And what is a gradient? The gradient is y2 minus y1 over x2 minus x1. So what is y2 here? This is 40, 41, 41, 42, 43. So that is 43. Minus y1, which is 29, divided by x2, which is 35, 36, 37, minus x1 is 25. So 43 minus 29, that is 14 divided by 12. So 14 divided by 12. That's equal to 1.16. So the gradient is equals to 1.16. Is it clear, this part?
Yes, sir, clear.
Okay. Then the next part, after working out the gradient, as I mentioned for paper 6, you don't have to memorize any formula. So 1.16, then calculate the mass of a ruler, meter rule, and use this equation. Mr is equals to m divided by g minus 1. And what is m? M is 20. This will be 20 divided by g minus 1. So it was 1.16 minus 1. So this will be 20 divided by 0.16. What's the answer? 20 divided by 0.16. 20 divided by 0.16 equals to 125. So 125 gram. And that is logical. A meter rule have a mass about like 100 to 300 gram on average. So it's logical, like this is having a 125 gram. Even the range of answer in the marking scheme, it's about 100 to 400. So again, you don't have to memorize any formula for paper 6. You just use. Now, two students carried out the experiment correctly, but they use different values of the mass. One student obtained a value of V that are larger than obtained by the other. State and explain whether the larger value are likely to produce more accurate values of a mass. Look, for example, if I say you're measuring 2 centimeter and you're measuring a 20 centimeter by using a same meter rule or a meter scale, which one you think will have a higher percentage uncertainty? Like more likely you will get a wrong result. A 2 centimeter or 20 centimeter? Which one you think, if when you're measuring, you may have an error, like greater percentage uncertainty? A 2 centimeter or 20 centimeter?
Yes. Yes.
2 centimeter.
Allah can even say shit.
2 centimeter will have more error as or greater percentage uncertainty as compared to 20 centimeter. So when you are measuring a larger values, because the idea is that when you're using the idea or the concept of the percentage uncertainty is the uncertainty divided by the value recorded into 100. Means when you're using a same instrument and measuring a short time interval, like example, using a simple example, a stopwatch. If I measure a time for one oscillation, say this time was 2 seconds, and I measure the time for 20 oscillations, which is, say, example, 20 seconds. So which one I'm likely to have an error? The 2 seconds I'm likely to have an error because I'm measuring a smaller value. So as a result, the percentage uncertainty will be high. So if we say that two students carried out the experiment and a student used a larger value of a B, so his experiment will be accurate, more accurate or less accurate? If he use one student use a larger value for B, so his result will be more accurate or less? So his results will be more accurate. And whenever you use a large value, it will be more accurate because the percentage uncertainty will be lower. So when you are measuring a small value, the percentage uncertainty is high. When you measure a large value, the percentage uncertainty is low. And this one likely you make an error, this one less likely error is there. Right? Errors are there, but the percentage error will be less or reduced. So this was a question one from balancing experiment.